Liquid limit is known as the water content of the soil that changes the state from being liquid to plastic and stops being liquid. It is the lowest moisture content of soil at which it flows like a liquid. The liquid limit, denoted by LL, is the transition point between the plastic and liquid states of consistency. It is also defined as the water content at which the groove in a soil pat cut with a standard tool flows together through 13 mm under the impact of 25 blows imparted by the Casagrande apparatus. Its objective is to determine the liquid limit of the soil using the Casagrande method.
These are the materials and equipments that we are going to need in our experiment. First is soil. This soil is also accompanied with a number 40 sieve. Second is distilled water. Third is Casagrande apparatus, which is also accompanied with an ASTM grooving tool, a ruler, and then a weighing scale to weigh the soil and other materials that we have, a metal dish, a spatula used for mixing, an oven that is used in drying, and a graduated cylinder that is used for measuring liquids such as distilled water. And that's all.
The first step in doing this experiment is to air dry the soil and make sure to pass it to a number 40 or 0.425 mm sieve. After you pass it to the sieve, check if the soil is fine-grained. Next, put the fine-grained soil in the dish and mix it with 15 to 20 ml of distilled or demineralized water by alternately and repeatedly stirring, kneading, and chopping it with a spatula. Further additions of water shall be in increments of 1 to 3 ml. Each increment shall be thoroughly mixed with the soil before another increment is added. Once testing has begun, no additional dry soil should be added to the moistened soil. The cup of the liquid limit device shall not be used for mixing soil and water. If too much water is added, the sample shall either be discarded or mixed and kneaded until natural evaporation lowers the moisture content. After, place enough material in the cup so that, when squeezed and spread with a spatula, the soil will rest in the cup above the spot where the cup rests on the base and will be 10 mm thick at the point of maximum thickness. Use as few strokes of the spatula as possible, taking care to prevent the entrapment of air bubbles in the sample. Next, divide the soil in the cup with a firm stroke of the grooving tool.
Lift and drop the cup by turning the crank at a rate of approximately 2 revolutions per second until the two halves of the soil pat come together along a distance of about 13 millimeters. If the soil just slides and don't come together, then get another soil and repeat the steps. Do not hold the base while the crank is turned. Record the number of blows required to close the groove this distance. Use the spatula to obtain a moisture content sample by slicing through the soil pat perpendicularly to the groove. Determine the mass of the empty dish first, then put the soil sample in the dish and also determine its weight. Repeat steps 1 to 7 with 4 trials with different moisture content and number of blows that is estimated to be within 10 to 35 blows. Put the sample in the oven and wait for 24 hours. After 24 hours, get the samples and determine each of the samples' weight. Lastly is to determine the moisture content of the trials. The trial 1 or the sample number 1 has a moisture content of 40%. The trial 2 has 22.2%, while the trial 3 has 42.857%. And lastly, the trial 4 has 120%. The logarithmic graph says the higher the moisture content, the lower the number of blows. And the formula of the logarithmic graph is y equals negative 58.9 logarithmic x plus 228.96. Therefore, the liquid limit in 25 blows is 39.368%.
The Standard American Society for Testing and Materials, or ASTM, and the American Association of Highway and Transportation Officials, or AASHTO, that we base our lab experiment on according to the DPWH Blue Book is the ASTM D4318 and AASHTO T89. ASTM D4318 and AASHTO T89 suggest the following procedures and formulas for calculating the data.